Hello everyone and welcome to this Derive tutorial. In this tutorial we will talk a bit about specularity. The reason is that specularity can cause some confusion sometimes because it's not as standardized as say normal maps are. Normal maps usually have the same information in the same color channels, and specularity not so much. With specularity, most shaders treat it like this. You can have a specular map, but you don't require to have a specular map. So if you don't have one, the shader will usually create or give the surface a uniform value for both the color and the specularity. Now, first off, what is specularity? Let's break it down to three components. First, you have the specularity value, which is only the potential glossiness of a part of a surface. Then you have the glossiness itself, which is multiplied by the specularity and produces a gloss. And the third component is the specular color. And we're going to go through all three of these, and we're going to iterate through the shaders that we can use in Derive for the preview. So let's get started. First off, I have a project open. This is the raw tiles project. That is an example that comes with Derive. And I have removed the specularity completely. So now we can see that the master node's specular map input has nothing connected to it. So let's get to the preview area and expand the settings. And now if I increase the glossiness, we can see that our surface becomes glossy, right? This is for the Derive mobile shader right now. But we have a problem. If we zoom in, we can see that we have specular highlights everywhere, even in the gaps between the tiles. I don't know if you can see very well. Let me just now you see it a lot better. If I increase the specularity, everything is specular, right? But we don't want the gaps to be specular. We want only the tiles to be specular and the gaps not. But since we haven't connected a specular map, the shader assigns a uniform value to the entire surface. So how do we fix that? First, let's create an append node, and this node will basically append all the components that we need for the specular map. But for now, we're gonna focus only on the specular value and not on the specular color. So I have this tile mask that you can see on the left, and this tile mask, I used it to assign the colors to the tiles. But we're going to use that same pattern for the specularity. So if I plug that in here into the alpha channel, and now I collect this append node. This append node now only has information in the alpha channel. It doesn't have any color information. So if I plug that into the specular map, now we see that the specularity highlights in the gaps, they're gone. And only our tiles are specular, right? Now, the tiles are still very uniformly specular. It doesn't look all that natural. Let me quickly show you how you can do that. I'm gonna add a math node and set it to multiply. And now I'm gonna add a noise node and adjust, modify the settings here, maybe a bit like this, and always make sure to map it seamlessly because noise is not seamless by default, and maybe also level it a bit up. Let's say new range from 0.6 to 1. And now we're going to plug that into the append node. And we see that we get a much more natural looking specularity, right? So This works the same for all shaders. If I use Derive's tessellation shader, whoops, here the color is a bit too bright. Let's tone it down like this. And parallax occlusion mapping should look just the same. And the Unity standard shader, whoops, it doesn't have specularity. And why is that? That is because Unity shaders, they work a bit differently, but we'll get to that in a moment. For now, let's stick with Derive's parallax occlusion mapping shader. The difference between the parallax occlusion mapping shader and the mobile shader is that the mobile shader only allows you to give the specularity a uniform color that you can select here in the settings. You cannot say this area has a different specular color than this area. And that is a limitation that oftentimes isn't very important. But if you have different specular color, say for instance, when you have a metallic surface. Now, say these tiles were not made of stone or ceramic, they are made of some a metal of some sort, then the specularity color will usually resemble the albedo color, or will be much closer to that rather than to a uniform color. And we can't do that with a mobile shader. But let's move on to the parallax occlusion mapping shader and see how we can do that. For that, I'm gonna make some room in my node tree, and I'm gonna start adding some nodes. First, I'm gonna get my albedo texture, right? And I'm also gonna use a saturation node because the colors are a bit too strong. I'm gonna desaturate it slightly like this. And I'm also gonna level it down because it's way too bright right now for a specular color. I'm gonna say like let's say 0.2. And now I'm gonna have to break that up into its individual channels and connect it to the append node by connecting red to red, green to green, and blue to blue. Now, nothing has changed in the preview, and that is because in the shader settings, we still have a uniform color set as the specular color source. To change that, let's use Specular Map Rgb, and now we can see that our tiles look a lot more metallic than they used. That's because now the shader is using the colors as specified by the specular map. So in this map, we have the specular value and the specular color. And if I move over to Unity standard shader, right now, yes, it does the same thing. Now, when working with Derive shaders, you only get to choose whether you want to have the specular color source read from the Specular Maps RGB, or whether you want to have a uniform color. And if you don't have a specular value, then a uniform value is automatically assigned. With Unity shaders, it works a bit differently. Here, you can choose whether you want to read the specular map from the Specular Maps alpha channel or the albedo's alpha channel. It means you can store the specularity information in both and choose in the Unity editor where it should read it from. The thing is that when you have a specular map in place, but choose to read the specularity info from the albedo's alpha channel, then Unity shader will read specularity from the albedo's alpha channel, but the specular color will still be read from the Specular Maps RGB channels, right? And that can cause quite a bit of confusion. If you don't have a specular map in place and choose to read the specular color from the specular value from the albedo's alpha channel, then Unity shader will assign a uniform color that you can choose from. And if you have nothing in place, like no specular map and nothing nothing in the albedo's alpha channel, and you choose to read specularity from the specular map, which is not there, then Unity will assign a uniform specular value just as Derive shaders, and a uniform color also. So yeah, I hope that clarifies a bit how specularity works, especially with the Unity standard shader. Derive shaders are a bit more simplistic in that regard, but now that you know that, you should be able to create some nice looking specular surfaces. And yeah, that's it for this tutorial. I hope I could help you, and if you have any questions, please head over to the forum or shoot me a message, and see you in the next tutorial. Bye bye.